Hi, Algebra 2. Sorry the computer crashed. This would be a short second part here, and left off where it was crashed. The screen crash was about the relative max and mins. So let's pick up right there, and we're going to solve them by finding them using second trace to calculate. And we have two mins to find. So let's start with one of those, second trace, and then for minimum we'll hit 3. When we go to find the maximum, we'll hit 4. So in this case, we're finding the first minimum, and we hit 3. Now again, the same calculator steps as the 0. You just have to make sure you're to the left of the minimum. So there's my cursor. My minimum is there. I'm going to go to the left and then hit enter. Then go past it, hit enter, and then move it onto the spot and hit enter. And it gives us the exact minimum. And it's negative 1.58. Remember, you would round if necessary. You look at the third decimal place, and if it's a number less than 5, then you'll round down. If it's number 5 or greater, you'll round up. In this case, it's a number less than 5, so our minimum is negative 1.58, and the y value is negative 9. Okay, so write that down here where we have relative minimum, and then I want you to go ahead and find the second one. What's fresh in your mind? Go ahead and run through those calculator steps and find the second minimum. So you should have found that the second minimum point was positive 1.58 and negative 9. So make sure you've written both of those in. Now to find the maximum value, we have to see it. So see how you can tell it went up and came back down? We need to zoom out to find that. And you can do that by changing the window or by just zooming out. Let's see if it works if we zoom out and move up. Let's go up closer to where the maximum looks like it is, and hit enter. Okay, now we can see it, but not so carefully, so let's go ahead and zoom back in that area. Okay, and now we have a good idea of that relative maximum. We can see that there. So to find that, we'll run through the same steps, the second trace, and instead of hitting minimum, we'll hit maximum, so we'll hit number 4. Now it wants to know left bound and right bound again. Remember, always left to right. There's our maximum, so we'll bring the cursor over here for left. Okay, once you're on the left, you hit enter, then you move it past the maximum and to the right and hit enter, and then guess by putting it next to the maximum and then hit enter. I'm glad this came up this way. Notice how the x value is this negative 2e to the negative 9. What that is scientific notation. So that's e stands for 10. The scientific notation, so it means negative 2 times 10 to the negative 9th power. And that number, if you think about what that looks like, let's write a thought bubble. So negative 2 times 10 to the negative 9th power, remember how small a number that is. So if we take negative 2, we're going to move this decimal place 9 times. So that would lead this to have negative point, all these zeros all the way to 2. So that number that you can see is a really small number, a number really close to 0. So if we pull up our graph, you can see that anytime this comes up and it's representing a very small number and we're a small number 0, the calculator is just over calculating and it should make sense to you. It should follow where the x is 0 or the y is 0. That will be your point. So our maximum point is, we're going to write down 0, 16. Okay. Then I want you to just take these points and I want you to graph them on your coordinate plane. So the maximum will end up being way up here off your graph if you don't change your units here. So if we want to change our units on the y-axis, let's go by 5s, I guess, 5, 10, 15, 20. And but on our x-axis, we'll go by 1s. And you just have to label that when you make that change. So once you label it, you go ahead and graph your points. So you graph your roots, -2, -1, 1, and 2. And then you graph your relative maximum. So 16 would be approximately here, maybe a little bit lower. And then your relative mins, -1.58 would be a little bit more than halfway to -2 here, and then -9 would be approximately there. And then 1.58, -9. Once you do that, then you draw your curve like it looks in the calculator. Okay, and it would look something like this when you graph it. All right. Our last part here, I want you to skip example number 2. We'll do that one in class. And then I want you to write down these two thoughts you already know. The first question was, how can you figure out how many roots a function has by looking at its equation? And you can do that by when you find the degree, and that number would equal the total number of roots. So that's what we were doing in the beginning of these notes. The second part was you can see your, how can you figure out how many zeros you have in the graph, and that's just by counting the number of x-intercepts. Okay. Okay, so we're going to go ahead and try that. Just first, the first problem here, we're going to state the number of roots. Our degree here is 3. So the degree, remember, always equals the total number of roots. So that would be 3. And then we use the graph to state the number of zeros. So there's 1, 2, 3. I'm counting. So the total number is 3. Okay, how you find the number imaginary is you take the total number of roots and subtract the real zeros. So 3 minus 3 is 0. And there's no imaginary. All of our roots were real in this case. So you find the total number of roots and the zeros, and then you subtract the zeros from the roots to get the number of imaginary. So for the second one here, our degree would be 4. That's the highest degree. And then we would count our x-intercepts, and we have 2. So in this time we have some imaginary, because 4 total roots minus 2 real roots, which are zeros, you'll get 2 imaginary. Okay, that's all I have for tonight. We'll be practicing this more in class. Have a great night.